Okay, so here is another GCSE revision video, this time focusing on natural hazards, prevention, protection and prediction methods. Okay, 3 key definitions, hopefully you can see them here. Prevention is about preventing damage and death to property and people, very, very similar really to protection, which is about protecting people from the impact of the hazard. Prediction though is obviously aiming to predict when the hazard will occur, and that's easier for some of our hazards than others. Okay, so on the board you can see a whole range of different methods. So you could have a seismometer, you could have a clear evacuation route, a clear evacuation drill, earthquake-proof buildings, effective and well-planned and well-organised rescue and emergency services. You can have satellites, which obviously track weather patterns for tropical storms and droughts. We've got diversion channels for volcanic eruptions. We've got tidal gauges, very useful for things like, again, tropical storms and tsunamis, for measuring storm surges and the height of the waves. And also, you probably can't see this, but this is lots of small children in Japan wearing foam hats, because in Japan they do an earthquake drill day, and these are the sorts of methods that they have to try and protect people as they're trying to get to evacuation areas or shelter areas. So that's a bit of an introduction. What I'm aiming to do is give you some clear examples that you can use for what are often 4-mark questions about methods that you can use to predict hazards and protect and prevent. Okay, so we'll start with our earthquake-proof buildings. Our earthquake-proof buildings have 4 key features. First of all, they tend to have an X structure which provides strength to the building, minimises damage if the building starts to sway, makes it less likely to collapse during an earthquake when those tremors mean that the building does start to sway. To try and counter that further, the foundations of the building are often built on springs, so similar to car suspension, which absorbs the bumps in the road as you go over it. Okay, these foundations, these springy foundations, they absorb energy from the tremors. You know, they've got that motion going on, and again, that counters the vibration of the building, minimises the chance of it coming loose from its foundation and therefore falling over. Counterweights are often put on the top of the building that are designed to counter the sway, so as the building sways one way, the weights are designed to roll back the other way to try and drag the building back, stop it swaying so far over that it risks toppling. Okay, so we've got our counterweights. And finally, our windows tend to have shutters that will roll down as like a tremor is detected, and that prevents any breaking glass from falling down on street level and injuring pedestrians who may be walking below. So a classic earthquake protection method is your earthquake-proof buildings. In terms of prevention, we've got our seismometers. Yeah, the most reliable thing that you can get, and still not absolutely perfect, highlights the problem of the difficulty of predicting exactly when an eruption will occur or when an earthquake will occur. Our seismometer uses a needle to record the strength of tremors, okay? So the needle just makes that motion, and it will make wider motions, make wider scribbles as those tremors occur and get stronger. And the closer together the lines become, the more likelihood there is of an earthquake occurring. But, as I said, it's still not 100% predictable. Or 100% accurate, I should say. Not predictable, accurate. Okay? So, as we say, the wider the needle moves, the bigger the tremor, the closer the lines are together, the more frequent the tremors are becoming. And then for tropical storms, satellites collect and record data to pinpoint more accurately where certainly tropical storms will occur. You can do it with earthquakes because you can use previous readings, but I would stick to satellites for tropical storms because you can obviously pick up and give regular updates to people. And then you can link that into things like, providing people with accurate information of when the storm is likely to hit within a time frame of maybe a couple of hours, and therefore you can put into place evacuation plans, you can direct people to storm shelters, you can encourage people to collect all their possessions and prepare your emergency services. As I say, other quick examples that we looked at the start of the video tends to be in MEDCs where you've got emergency services who are well drilled. They practice earthquake drills and volcano drills and hurricane drills regularly so that they know what services are responsible for doing what things. That minimises the casualties, minimises the amount of damage done. Volcanoes, 2 very popular ones for volcanoes. You've got your evacuation routes so people know the safest way away from settlements that surround volcanoes and can therefore escape quite easily. And we also have diversion channels, either made already. There are some areas in Japan that have their diversion channels already made, or they are made during the event by sort of dropping bombs onto the landscape and trying to blow sort of channels that the lava can run through. And as we said, going back to where we finished, really, a classic case from Japan, that earthquake day, so that everybody knows what the drill is for when an earthquake strikes. And it's providing, you know, safety equipment for children. There are little shelters erected in cities, and also they know what to do in buildings. Okay, so make sure you know a good selection of tectonic methods and tropical storm methods. Thanks.